Okay, question 13. Scientists have used chemicals to produce polyploids to try to improve the characteristic of kiwi fruit plants. Now, you don't need to know about polyploids anymore, which always upsets me because it's such a cool word. But the first section of this is still totally valid for you to do as problem solving, so I've left it in. Okay. Second bit, you don't need to know. Okay, so what we've got is characteristics of fruit from the original diploid plant, which was 2N, and the two polyploids produced from it, 4N and 6N. So even though you don't know about polyploids, you could figure out what's going on here. Okay, so what we've got is changes in the number of sets of chromosomes which we have. So you've got characteristics of fruit, you've got the fruit mass, the fruit length, the fruit diameter, and the vitamin C content in units. Which characteristic is least affected by polyploidy? So we're looking for what changes and what doesn't. So we have the average mass of the fruit, 96.5 going up to 145. That is a pretty big change. Okay, we've got our fruit length, 74.4 going up to 86.8. Again, that's a reasonable change. Okay, our fruit diameter, 51.7 increases to 60 and then stays the same. So there we go. And just to check, vitamin C content, 123, 119, 124. Actually, I prefer my vitamin C content now. Okay, so which characteristic is least affected by, given that this has got the least variation, I'm going to go vitamin C. Always check to the end. Okay. Describe the relationship between polypoidy and average fruit diameter. Right, this is a bit of a gift. So you don't need to know anything. Okay, average fruit diameter. So at 2N, the average fruit diameter was 51.7. It increased to 60 millimeters by 4N and then remained the same. Treat it like a line graph. That's it. Okay. Calculate the percentage increase in average fruit mass when the chromosome number is doubled. So average fruit mass, we're going here. The chromosome number is doubled. I have to use my 2 and my 4. So I've gone from 96.5 to 115.8. Okay. Percentage increase is the same as any percentage change. So percentage change equal to, I need the change, divide it by the start, times it by 100. Okay, calculator out, 115.8 minus 96.5. So we have 19.3 divided by 96.5 times it by 100, 20%. Okay. So C is no longer in your course content at all. It's non-disjunction if you want to look it up. And D is not totally there, but the idea of gene duplications is still. Okay, so I think that's still worth looking at. Polyploids have whole genome duplications. Explain the importance of this in evolution. Gene duplications and genome duplications, same deal. Okay, if you have a duplicate of a gene or whole genome, it means that you now have 3 copies of a particular gene, assuming it was a gene duplication, not a genome. Genome would give you 4. Okay, but if you have extra copies, it means that you have a functional one that you can still change the other, and it's not going to affect the fact that you can still do what you should be able to do. It's the belt and braces idea. Okay, that you can still test things out while altering other stuff. Okay, that's it.